Hi, folks. Hope everyone's doing well. I am Karthik, one of the co-founders and CEO at Yugabyte. And we build a distributed Postgres database for cloud applications, for large scale, for multi-tenancy, multimodal, et cetera, et cetera. So making applications, the world of applications, easier, right? So, at the onset, you may ask, what the hell does this have to do with open search? Well, it turns out that search is an important component of real-time applications, right? So working with search, enabling search, Postgres has some search, and open search has a lot of other features in search. How do we bring all this together? And let's not forget vector search, and how do we deal with the AI? I think a lot of this is our perspective, right? I hope you guys were listening to what Fernando said, because that kind of set up the problem statement for what we do really well. So I'm going to build a lot on that, and I had it in the slides anyway, so it's not like I'm changing it on the fly. But I do hope you guys paid attention to search being complicated. So I'm here to talk about how you design, architect, and power applications in the world of AI, and specifically what you can use as a substrate and what's going on. So the first thing here is there is an explosion of AI-powered use cases. I think Fernando was saying it's growing. The AI MAUs are growing like crazy for them. It's the story everywhere, right? And if you look at it, and if you can actually look at the graph at the bottom left, if you can read the years, it's like an eye exam, but if you can really manage that, the biggest bar to the right, which talks about the growth, is in 2034, right? And if you keep going back, we're at 2024, that's the first bar. And we're not too far from that, we're in 2025. So what do you see? The first two bars are pretty damn small, and it starts to get bigger a couple of years out, which means we're building for exponential growth, right? We're not there, but that's what we're building to. And you already, if you haven't heard of agents, I mean, come on, you gotta really ask yourself if you're even checking social media news or anything. And there's been 2,049 AI companies in 2024, right? And you can do the math to see where it's gonna go based on the graph on the left. So, bottom line, a lot of AI, and maybe not all of it materializes, but it sure as hell isn't going to go to zero. That means it's going to settle at a steady state. AI may settle at a steady state, but the output of AI will still be exponential, right? That's important. Okay, so preaching to the choir probably, but RAG-enabled search engines, everyone's making it the default. Question answer systems, I've stopped reading PDFs. I want to interact with PDFs. I'm sure a lot of you guys do, especially if it's like 20, 30 pages long. Like, just tell me what the hell's going on, and I'd ask 20 questions and get my answers, right? Far easier as a user experience, how humans comprehend. Similarly, like product personalization, I mean, you can read it, like manufacturing, healthcare, it's starting to go everywhere. Legal, like if you've seen those documents, they're huge. It's far easier to interact with them, right? So, and a lot of other examples. It's starting to percolate everywhere. Right? Now, what does this mean? AI starting to percolate everywhere, right? Obviously, when a new technology comes up, everybody tries to add a little bit of it to make sure their applications get enhanced. Okay, and then they add a little more, and then a little more. And the last feather will break the camel's back. And you have to step back and think, what am I supposed to do differently, right? And this is what this slide is about, right? If you're thinking differently, exponential growth. That's what you have to get prepared for. And, well, fortunately or unfortunately, the human mind totally sucks at trying to understand exponential growth. We're not good at it. We're not built for it. We know how to do things linearly in weeks, in months, in years. There's a saying that people often overestimate what they can do in a week and underestimate what they can do in a year. And, that's even more so, exaggerated if you're thinking of exponential growth. Right? So the key principle from all of this is if you're not able to truly visualize what you can do 3 years out, well, then you better be ready to adapt for whatever comes your way. So we've always grown up in this industry by thinking, build systems that last forever, right? Well, the first time we have to say, build systems that are designed for change, right? But we have to kind of use this judiciously. It doesn't mean like, I built something, throw it away, 6 months later, build it again, throw it away. That's not what it means. It's more like build systems that last to be able to iterate, right? So you have to be able to iterate. Designing for that flexibility will become the most important thing that we do, right? That's the next era. Okay, so what really changes, right? We talked a lot about the build cycle, right? Like this is how a rough build cycle looked in the cloud native era when we were building cloud native applications. You'd have an idea, that's innovation, and then you put it in and you release it and people like it, and then you get ready for growth, more people start using it, and now you have a bunch of outages, scale, blah, blah, you deal with it, and then you come back and you have sudden spikes and failures and other things that you have to deal with. You maybe have a brand or a monetization problem because of that, but it's a good problem to have because, hey, you can always do this after you prove the success, and then you come back to add more ideas, and this cycle keeps going round and round. Okay, so what changes in the post-GenAI era? Actually, nothing. The cycle remains the same. The speed through which you go through each of these stages has become incredibly fast. It's gone from months/years to hours or minutes. So you're going much faster, right? So software is doing stuff that people did, and people are taking care of the software that now does stuff instead of them. And the software never sleeps, right? And you can always scale it. So that's really the only change. Like the principles, the fundamentals don't change, but the speed at which you iterate changes, the scale at which you operate changes. And if you listen to Fernando from Atlassian, same problem for everybody, right? Once you impose scale and once you change the rules of speed, it becomes a very complex and different problem. So a lot of examples, right? You need to update all the apps that are working to work in this kind of a world where you're designed for a super fast innovation cycle, right? You start to use some LLM to prove that it works, but pretty soon you'll find there's a better LLM, there's a cheaper LLM, there's an LLM that's not allowed anymore, and you have to change, and so on and so forth. So that's change. You'd have to do more efficient development and operations. What is the real architecture, though, that you're building against? It's going to keep changing, like RAG, like is it RAG or not? Is it in or out? Like, are you doing SLM or LLM? Are you doing MCP or A2A? Or is it even MCP that's going to stand the test of time? Well, you don't know, but you have to keep iterating, right? And your scale, you can take 6 months. You could have taken 6 to 9 months to have done it so far. You could have taken 2-3 years to have done it before because there was no cloud. Now you could actually order VMs in a matter of minutes, so that's not the bottleneck, which means you can take 6 to 9 months in order to scale your application now. Pretty soon it's going to be in minutes or hours. You're not going to be able to re-architect and redo the whole thing, so you have to think differently, right? And similarly for performance tuning, and so on and so forth. So it's going to cause a lot of upending, a lot of change, right? What type of change? Your first expectation is build and iterate quickly, right? And one of the key things that we're seeing happening, and very relevant to Yugabyte, is the fact that Postgres is becoming the de facto standard. And one of the reasons why these type of standards are starting to emerge is that you have to know the system to build something on the system, right? You keep changing the API or you keep picking a new database, well, good luck to you, because you first have to learn what it does, and that's going to take a long time. And unlike what everybody says, AI is not going to learn the system for you, because AI learns what you teach it, and you teach it by what you've done before, and what you've done before will now dominate, right? So it's kind of the power of standards is becoming more important. The second thing is you have to re-architect a large portion of your stack for iteration, speed, and flexibility, because pretty soon everybody will have access to all of these open source models, et cetera, and the one that learns the quickest and is able to imbibe those changes is going to be the winner, right? That's really the way the race plays out. And as you succeed, you will see more scale. If you take downtime in order to achieve that scale, that's a window of opportunity for somebody else. So don't let your success be the reason for your failure is an important principle to start thinking. There's no prototyping anymore. Your prototype is already a big application really quickly, right? And this is shown by the industry. A lot of applications are working this way. Okay, so let's look at what the application to build a modern GenAI app looks like, right? Like these are the actual steps. This is the pipeline. You have a DB with an existing app, which hopefully you're enhancing, because if you're just doing AI isolated from everything else, its application is limited. You want to enhance existing apps or build actual applications that people interact with AI. So if you look at it, there's a whole bunch of steps here. And in order to go through all these steps, I'm not going to go down the details, but you have to understand RAG, MCP, and architecting scale, resilience, the fundamentals upfront. You don't want to do this on the fly because that's the downtime that you cannot afford, because remember, there's no 6 to 9 months downtime anymore or even more, and you have to be able to ready to do it right in the beginning. Okay, so on the RAG architecture, a lot of clouds will tell you how to build RAG architectures, right? The problem with these architectures is they don't attach to an existing application. They talk only about the RAG pipelines. But your data comes from somewhere, your data is being consumed by somebody, and the data and this pipeline is in service of making something better for the customers or the users. So you are doing all of this to make something better, not doing all of this to do all of this, right? That doesn't mean much. So it's important to remember that existing applications, when you infuse them with AI, there are 3 distinct things that come up. The application data, the vector index that you're adding to it, and the bridge between the vector index and the application, which is what the human sees. These are the chunks or the snippets that you show. After I do my search, you're going to show a snippet, and the person really likes it. Show me more. Now you'll show the whole thing, right? So there's 3 pieces that start to come in, and if you're starting to use multiple systems to put them together, that makes it hard, right? This is a place where like a database like YugabyteDB helps, because we're able to scale, we're able to be elastic about the number of indexes you add, and make it easy for you to add them in place and burst according to what you add. Now, this is also where systems like search will start to come in, because this flow is not just for transactional applications with vector search. Vector search is often enhanced or combined with your semantic search, which is what OpenSearch does. So it's also something to think about. Again, not my area of expertise specifically on how you layer that in, but it is something that's important to think about at an architectural level. So, YugabyteDB supports the pgvector interface. Pgvector is pretty standard, like as an AI piece, and it supports the Postgres interface. And Postgres is well connected with vector search, so you can bring the whole thing together in order to build a modern application stack, right? And the important thing about YugabyteDB or Postgres is your ability to interact with the ecosystem, right? That's everything in AI. You have to be able to use the set of tools you like and iterate with the set of tools so that you keep making your service better and better. Bottom line, a lot of talk about specialized databases that do a lot, very specialized models. Remember, you're building to iterate. You get something 99% right, you can iterate your way to 99.9999, because that's the name of the game, right? Unlike before, where you had to build straight for the most precise thing. So these are some of the things that Yugabyte does, like, we power vector search, we help make things scalable and extensible, as well as resilient and, global, right? And, I made these slides before Fernando spoke, so, I'm not just making it up because of what he said, right? So anyway, second thing is MCP server, and again, I'm going to speed up for time. People's interaction is changing. MCP is one way to interact with data. It's a very intuitive way for humans to interact with data. There are other ways to interact which will continue to exist, APIs, UI, other ways like apps on the cell phone. They're not going away. So remember to add this as another access pattern and not the sole access pattern, right? So lot of things going on here in MCP. Again, the slide is busy because the space is busy and you have to pick out what works, and what works today is probably pretty surely not going to work 6 months from now. It's going to be something different, right? So, and the third thing to remember, make sure your fundamentals are good. You don't want to have the job of fixing your foundation after your building is already in service. That's really, really tough. So resilience is important because an AI-powered app that does all the fancy stuff will quickly lose its shine if it has basic problems like, oh, sorry, we're down for 6 hours because we need to do a patch or something like that, right? So most folks struggle with resilience in the cloud-native world. And the challenge is you're building reliable systems on top of fundamentally cheaper but unreliable systems, right? That's hard, and that's kind of an architectural choice, and it sometimes comes with a tax on how much you have to invest up front, but it's well worth paying. So this is an area we specialize in. Resilience and reliability is one of the core that we bring to Postgres, so that's why we call it distributed Postgres. It's about resilience and scale. And resilience, people think of it as, it's just like a node fails and I'll have another node take its place, right? And hence we use the word ultra resilience for people to really think about what it means to have your service running. So node failing is one piece. But what happens if your data center is actually down, or it's cut off, or it's partitioned, or you want to do a simple software upgrade or a security patch? What do you do? Or so on and so forth. There are gray failures where it doesn't go down, it's kind of not working well. And you have to detect those and fix it, because ultimately it's really about the application running, right? And so I'd say these are some of the things that we work with, and the principles are generic, even though we apply them to the database itself. There's a whole bunch of value that this brings, but I think as an audience, you folks, you can see the list, but it's the way we iterate, right? Make the foundation strong and then iterate your way. So that's all I had. Thanks, everybody. You can drop by our booth, the Yugabyte booth, and talk to us if you're interested in learning more. Thank you.
Thank you so much.